Welcome back. We are discussing Chapter 5 graphs, Lesson 2 interpreting graphs. Graphs are often used to model situations. This graph shows Siobhan's daily jogging routine. We have time here, and there's speed. Number 1, she jogs uphill at a steady speed. So that means here, we don't know exactly what the number is, but we know that the speed is steady, which would mean it would be the same. So as time increases, she is jogging at the same speed, and that's why this is consistent. It says the first part of Siobhan's run is uphill. Her speed is constant, so the line is level. So whenever you have a constant speed or a constant something, the line is going to be level here. The second thing it says is when she starts to run downhill, her speed increases. So she's running uphill, her speed is the same, time is going on, and then what happens here? It looks like her speed gradually increases over time. This says when she starts running downhill, she runs faster, and that's why the speed is increasing. The line goes up to show the increasing speed. So this is just an example of a model of a particular situation. So let's go ahead and look at these two examples here. It says number one, complete the graph for each situation. Number 1 states that you pour warm tea into a glass, then add ice cubes. So we have warm tea. Warm tea is going to be at we have a graph that's talking about time and temperature. So the first part of this graph is done for us. And so what's going to happen is that the tea is warm, so it's at a kind of a consistent temperature right here. It's remaining the same for this first bit of time. But then what happens is we add ice cubes. And so what's going to happen to that temperature? Is that temperature going to remain the same? Is it going to increase or is it going to decrease? Yes, the ice cubes are going to make the tea colder, so the temperature is going to go down. And it's going to go down until, the ice cubes melt. And then once they melt, then what will happen is that the temperature of the tea will remain constant at whatever that room temperature is, wherever the tea is. So this is an example of a graphical model of what this situation would be. Okay, let's look at number 2. Number 2 states that you are watching TV and lower the volume during a commercial. I mean, yeah, because commercials, it's like they pump up the volume. It always gets really extra loud, and who wants to listen to that? So let's go ahead and figure out what a model of that would be. Okay, so you are watching TV and lower the volume during a commercial. So here, the first part of the graph, this would be we're watching TV. This is time. This is the volume. The volume is high. We're watching TV, watching TV, watching TV. Oh no, here comes a commercial. So we lower the volume because we don't want to listen to that commercial. It lowers pretty quickly, and then it remains constant at that low temperature while all the other commercials are going on. So it's going to be a flat line, and then, oh no, our show's back on. So we turn that volume up really, really quickly, and then it is back at the same volume to watch the rest of our show. So this would be a graphical model of that situation. Okay, let's go on to 3 and 4. 3 says you bike from your home to the park, you play softball, then you bike home. So you bike from your home to the park, you play softball, then you bike home. So this has actually 3 different components to this problem. You bike from your home to the park. So you bike from your home to the park, you play softball, and then you go bike home. So in our graph, we're going to have 3 different segments. So this x-axis represents time, and the y-axis represents the distance from the home. Now, we don't know how much time and really don't know actual distance, and that's okay because this is just kind of like just a model, like a general model. It's not really super specific at this point. So we start at time 0 and we're at home, so the distance from home is 0. So we start right here at the origin. And we're going to bike from our home to the park. So once we start biking, the time starts ticking and we get further and further and further away from our house. Okay? So this represents the pink part, the pink part of this problem. You bike from your home to the park. So this is showing that we are biking from our home. We're getting farther and farther away from our home, and time is continuing. Now what's going to happen is we're going to arrive at the park. We're going to play some softball. Well, when we're playing at softball, time is going on, but we're not getting any further away from our house. We're remaining the same distance away from our house. So this is going to represent constant. So this yellow portion of the graph is us playing softball. Now we're done playing softball and we bike home. So as we bike home, time is still going, but as we bike home, we're getting closer and closer to our house until we arrive at home. So this line right here, slanted downward, would represent the orange portion of this problem. Okay, great. On to problem number 4. It says, you drive at a steady speed, you hit a traffic jam, slow down, and travel at a slower speed. Then the traffic jam ends and you travel at a faster speed. Okay, so there's a lot going on here. You drive at a steady speed. Okay, you drive at a steady speed. Okay, so that would be the first part. You're driving at a steady speed. You hit a traffic jam. Okay. So we hit a traffic jam. You hit a traffic jam. Slow down. And then travel at a slower speed. Then the traffic jam ends and you travel at a faster speed. Okay, so then the traffic jam ends and you travel at a faster speed. Okay, so let's go ahead. This graph has time and it has speed. So as I'm thinking about this problem, excuse me. Okay, as I'm thinking about this problem, we're talking about driving. It says you drive at a steady speed. There's two ways to think about this. This is, are we stopped and then we're driving at a steady speed, or does the graph start once we are driving at a steady speed? And so it isn't really specific about that particular thing, because if we are stopped and we weren't at a speed, it would be at 0, 0, and then we would increase our speed and then we would drive at a steady speed. But this just says you drive at a steady speed. So I kind of think that we're not starting at when the car is stopped. We are starting, this graph is starting when the car is already in motion. So that's how I'm going to model this, is because all it says is you drive at a steady speed. So I'm just going to go with what this is saying. I'm not going to talk about the car being stopped and then speeding up to a steady speed, because it doesn't say that. So we're just going to start at the car driving at a steady speed. So we're already going to be going a particular mile an hour. And we don't know what that is, right? But it will be right here. So we are traveling at a steady speed. Steady means it's not changing, it's remaining the same. So here it is steady, it is constant. We're going the same speed as time is going on. So that is that first little that represents you drive at a steady speed right here. Okay? Then what happens is you hit a traffic jam. So we're going at a steady speed and then boom, there's a traffic jam. And a lot of times when you see that traffic jam, you have to decrease your speed pretty rapidly. So you're slowing down, okay? And that's a pretty rapid slowdown. So that would be this, you hit a traffic jam and slow down. And then travel at a slower speed. So now we're going to travel at this. It doesn't say you slowed down to a stop. It just said you slowed down. Okay, so we're just gonna go with that. You hit a traffic jam and slowed down. So we're gonna slow down and then we're gonna travel at a slower speed as time goes on. So this would be this would represent the yellow portion. Then it states that the traffic jam ends and you travel at a faster speed. So the traffic jam is going to end and we're going to speed up. And then once we speed up, we're going to continue going at that faster speed. But we're not going to keep continuing forever and forever and forever. We're just going to continue up to the speed that we were going before the traffic jam, and then we're going to continue on at that faster speed. So that would be the pink portion there. So yes, this would be a model of this situation. So we will see you next time.